My name's Ben Upcroft. I'm going to talk a little bit about some of the research that we're doing at QUT, particularly in mining, but I'm going to focus on some highlights that we're doing in robotics and automation. So as we know, in the construction domain, robotics is ubiquitous. One of the reasons is that I can control the environment, we can control the environment, and we can hard code in what the robots need to do. So why don't we see robots in everyday lives and other domains as ubiquitous as manufacturing? I don't know what's going on here. We'll start again. The reason is in these other domains, environments are changing, they're dynamic, and we can't possibly hard code in every single possible thing that the robot's going to encounter. So how do we overcome this? What we believe at QUT is that if we make robots see as humans do, understand the world as humans do, then we can see the potential of robotics in our everyday lives and all the domains, including mining. We see automation in mining more and more. It's increasing. To be able to give a robot situational awareness and understanding of the world can only enhance productivity, safety, and efficiencies in any of these domains, including mining. So one of the centres that we have at QUT is an ARC Centre of Excellence in Robotic Vision, and it's really focused on this, creating robots that see as humans do, understand the world as humans do. This is a multi-million-dollar centre with a number of collaborations in universities and institutions around Australia and internationally. We see two fundamental competencies in this that we're trying to address in the Centre of Excellence. One is navigation. We have to be able the robot has to know where it is in the world and has to know where the rest of its body is relative to itself in that world to perform a task that we're asking it to do. The second competency is actually understanding what it's seeing, what is it seeing in the scene, understanding what objects are there and how they can interact and making high-level decisions on what it's observing. So I'm going to focus on the navigation and the scene understanding. I'm going to give you two highlights of some of the things that we're doing at QUT. So what's the problem with navigation? First off, I need to be able to localize and map. I need to be able to understand where I am and build up a map as I localize within the world. We've been able to do this, and you can see this in mining and automation for a number of years now. We can build up maps just from a webcam over hundreds of kilometres. We can build up 3D models from a whole bunch of different viewpoints, underwater, ground, and aerial. So what's the real difficulty here? Well, we see the real difficulty in that I can do all that when the environment's the same and it looks the same all the time. As soon as I encounter scenarios or conditions where are very, very different conditions, such as a tropical storm in Brisbane or a sunny day, how can I localise or find where I am with respect to the time when I did record that data? Here you're seeing here is a sunny day where we've driven through Brisbane, and then I've driven through in a tropical storm in Brisbane, and I want to localise that the nighttime video sequence with the daytime video sequence completely automatically. And what you're seeing here is what we're able to do this autonomously, automatically, able to figure out exactly where we are, even in conditions that a human wouldn't be able to achieve. We're often outperforming humans in a lot of these scenarios. You can see this being the potential of this, not just on a road, but in conditions that are snowing, dusty, underground, etc. This is the biggest problem for autonomous driving at the moment, being able to deal with localization in really terrible conditions. If you see the Google car, they're unable to do this yet, and this is really what a lot of the autonomous driving companies are trying to achieve. You can see the potential in mining, where I do have conditions where I need to be able to deal with this type of weather. I'm going to move to, one highlight. The second highlight is understanding what's happening in the world. This is some computer vision work coming out of Stanford, and they can just from an image can recognise objects, understand what's happening with those objects, and create an understanding of how they interact. I apply the exact same algorithm and the same parameters to something new, such as a haul road, and I get nonsense. These red squares, what it's saying is it's recognising them as people, but we know them as bushes. So we're working on a lot of this, understanding the world, improving these algorithms, And here's some stuff where we're trying to work on safety and trying to recognise just light vehicles and people in the scene. And you can see just a quick video at the top here. On the bottom, some really difficult situations at night, at daytime. We're able to recognise humans and light vehicles for these safety opportunities. So just I'm going to end on that, but we've got just some examples of research at QUT. We've got funding from ARC, Microsoft Research. We've got one of the most highly cited papers in this area in robotics. We've got a number of awards, innovation awards, the Edison Innovation Award in the US, which is one of the biggest innovation awards in the States, and a number of best paper awards and collaborations. So thank you very much.